Hello, honors pre-calc students. So we are moving on to learning target 5. This material is not going to be on your quiz this Friday, but so please just take notes, listen, and then prepare for your quiz, which is going to be on solving and transformations. So this learning target 5, though, however, is connected to kind of learning target 1, where you found domains. And so it kind of has some of the same challenges, but not as much. These two do go kind of hand in hand. Okay, the operations are things you really already know: division, multiplication, addition, and subtraction. There's a fifth one with functions called composition, which we'll get to in another video. It's first just the four basic. You can divide functions. You can divide any two functions, and x is your domain, your input. It happens to be this notation is the same as f of x divided by g of x. And this is f times g of x. Always need the domain, which is the same thing as f of x times g of x. And if you add two functions with the same domain, it's the same thing as taking the functions individually and then adding the results. Same thing with subtraction. It's a colossal mistake to think that you're distributing. It looks like you're distributing, but you're not. Remember day one, what distribution is? Distribution is a combination of multiplication and addition, and you don't have multiplication here at all. This is f plus g of x. X is the domain. It's telling you what the domain is. It's not times x. So that causes problems down the road. So it looks like the result of distributing x, but it is not. Let's get to some examples. So let's have two functions, f of x equals 3x and g of x equals negative 2x plus 5, two lines. And adding, subtracting, and multiplying them, that's not really the issue. The bigger issue is finding the correct domain, okay? Now, whatever the answer happens to be, it has to, the domain has to respect the original two domains. It has to, it's a combination, it's a creation of two separate domain functions, f and g. So both of those domains have to come into account when you display your final answer. Here, it's not too big of a deal because 3x is a line which has the domain of all real. And same thing with g of x. G of x is another line, and the domain is all real. So there's no real issue here, but there will be an issue later on. F plus g of x is the same thing as f of x plus g of x. And you know what f of x is? It's 3x. It says it right here. And you know what g of x is? It's negative 2x plus 5. So you just add them up, and you would add carefully to get 1x plus 5. And this is a line, and this has a domain of all real numbers. Now, it doesn't have a domain of all real numbers because this is a line. It has a domain of all real numbers because this is created from two functions that have a domain of all real numbers. F minus g, just as easy as that first one. It's the same thing as f of x minus g of x, which is 3x minus negative 2x plus 5. Don't let subtraction ruin your potentially awesome SAT score and destroy it, because you're subtracting g, and g is composed of two different terms. So you need to group both of those terms when you're subtracting. So you need parentheses, and you distribute that negative 1. So this is really 3x plus 2x minus 5, leaving you with 5x minus 5, domain of all real. F times g, well, we know how to multiply. Just fx, 3x, times g of x. And now here you distribute, because here you were combining addition with multiplication. So you distribute 3x times negative 2x, 3x times 5, which gets you this, negative 6x squared plus 15x. Again, the domain is all real because it came from two functions where the domain was all real. But this is where things change so slightly. F divided by g. Well, f of x is 3x, which is a domain of all real. G of x is this line, which is a domain of all real. But the result doesn't have a domain of all real because we are dividing. And you have to be, as mathematicians, you have to be ultra sensitive that whenever you're dividing, something inside you needs to say, can't divide by 0. You have to check that you're not dividing by 0. We'll get to that in just a second. So first of all, f of x this is just 3x divided by negative 2x plus 5. Now, what is the domain of this? Well, it came from two functions that have a domain of all real numbers, but you are dividing, so you cannot divide by 0, so you have to find the x value that makes you divide by 0 and then exclude that. And please show me your work. Please, please, please show me your work. Here's the denominator, negative 2x plus 5. Solving for x gives you 5 halves. So when x is 5 halves, negative 2x plus 5 equals 0, and that's a problem because you're dividing by negative 2x plus 5. So the domain for this answer is all real numbers except for 5 halves. And here's how we write that in interval notation. From negative infinity all the way to infinity, but you're omitting 5 halves. Here's where it gets a little bit, okay, so this domain problem gets a little bit more interesting here. We're gonna do the same 4 things: add, subtract, multiply, divide. But the two functions are different. They're both square roots. Now, f of x is x plus 12. That has a domain of negative 12 to infinity. As long as x is negative 12 or bigger, you're taking the square root of a positive number here, or 0. And for g of x, remember, this is just as simple as taking 3x plus 1 is greater than or equal to 0. And you're solving for x. That's the work that I want to see when you're doing your quiz or your test or whatever. You solve for x, and you discover that x is greater than or equal to negative 1/3. Now, when you add them, you're getting a new function. What's the domain of that? Well, it has to be a domain that is like acceptable to the two functions that it came from. So what is the domain going to be? And first of all, let's just get to the answer. F of x plus g of x is just the square root plus this other square root, and that's totally simplified. And the domain is from negative 1/3 to infinity for this answer. How come I can't use these numbers? Because these numbers over here would create a problem for this square root. Got a little graphic. So this top number line, this blue represents the domain of f. Here's 0, so here's negative 12, and everything past negative 12. The bottom blue line is the domain of g, starting at negative 1/3 and going over. Now, what x values do both of these share? What do they both have in common? And that is this red arrow from negative 1/3 all the way to infinity. When you're asking the question, what numbers do two sets have in common? In math, that's called the intersection. So we're finding the intersection of these two domains. Again, because the result came from a combination of two different functions. So you have to find a domain that is acceptable, that is allowed for both of those functions. And that is this domain, everything from negative 1/3 to infinity. F minus g, just as difficult as that first one. Just the square root of f, the f function minus the g function. Same domain for the same reason. F times g. Well, you have two separate domains, and when you're combining them, you need a domain that they both agree on. And here, your homework is going to be on My Math Lab, and My Math Lab, God bless it, wants you to simplify. So here, this is great practice because this multiplying two binomials is an Algebra 1 skill, and there are a lot of Algebra 1 questions on the SAT. So don't begrudge me for having you do this. You're multiplying these two square roots, which they have the same index. They're both square roots, so you can multiply their radicands. And a binomial times a binomial, you're going to double distribute and get this. And the domain is from negative 1/3 to infinity. Now, I want to pause here and just briefly talk about a little oddity here. On the previous quiz, you were faced with a question similar to this. Like if I just gave you this function, if you didn't have any of the history, I just gave you this. What is the domain of the square root of 3x squared plus 37x plus 12? You would hopefully realize to factor this, and you would, by factoring, you would get this, and this would be, you would have the two zeros. One of the zeros is negative 12, one of the zeros is negative 1/3. Now, normally parabolas have a domain of all real numbers, like you know, but this function, you're taking the square root of that parabola. Well, you can only take the square root of positive numbers. So what x values produce positive numbers for me to take the square root of? It would be everything to the left of negative 12, but then also everything to the right of negative 1/3. So the domain would have two intervals. How come I don't have that domain here? This is a subtle point, which I will happily repeat. The reason this is the correct domain for this problem, because this came from these two functions. You kind of have to look at the whole problem, the whole history of the problem. And this just didn't come out of nowhere. It was the result of f times g. So you have to consider both the domains of f and g, figure out where they overlap, and then that begins the domain answer. Same thing with f divided by g. F divided by g will have almost the same domain, but with a new problem, you're dividing by g. So you're dividing by something that has the potential to be 0. So what x value would make this be 0? Only negative 1/3. So the domain for this answer is the same as this, except it excludes negative 1/3. So there'll be a parentheses instead of a bracket. But there's some blue boxes here. So what are we missing? Well, it's not simplified because typically they don't, it's an archaic rule, but no square roots in the denominator, basically. No square roots in the denominator. So how do you get rid of the square root that's in the denominator? You do something called rationalize the denominator. So you multiply both top and bottom by the square root of 3x plus 1. That'll do it. And it seems like a lot of work, but you already did a lot of the work. You did a lot of it. First of all, the denominator, when you multiply these two, the square roots cancel out. And so you're just left with plain old 3x plus 1, a very rational denominator. The numerator is, you already did the work for the numerator back up here. So the numerator is the square root of 3x squared plus 37x plus 12, all over 3x plus 1. And the domain is greater than negative 1/3, because negative 1/3 would make you divide by 0. This is my favorite slide, and this is the last slide, so I hope you're still awake. Here's a graph. The better you are at seeing graphs and analyzing graphs, the happier calc student you're going to be next year. So you got two functions, f and g. G is the maroon, f is this dark blue. What is the domain of f plus g? Yikes, f plus g of x. Well, again, you're combining two functions, f and g. So you need to find a domain that they both agree on. F has a domain between negative 4 and positive 3. That's represented by this blue horizontal bar. G has a domain between negative 5 and positive 5. That's represented by the maroon bar. Now, what x values do the blue bar and the maroon bar have in common? That again is called the intersection. So what they have in common is the x values between negative 4 and positive 3. Just so happens to be the same domain as f. That's just a coincidence. You're really looking for where do they overlap. Like if f was shifted to the left, then they overlap right here between negative 5 and negative 1. That would be the domain of that would be how I find the domain of these. But it isn't that way. It is how it is right here. The domain, when you combine the two functions, the domain is between negative 4 and 3. And so therefore, that's the domain. Now, what is f divided by g? Well, Naturally, it would be the same domain as this, except you're dividing by G. So there's potential for a problem right here. G cannot be 0. So look at G. Does G ever equal 0? Yes. G equals 0 when x is -4. So -4 can't be in the domain because that would make you divide by 0. You're dividing by G. When x is -3, you're dividing by 1 because G of -3 is 1. And G of -2 is +2. But G of -4 is 0. And so that's a problem. But then also G of 3 is a problem because when x is 3, G is 0, and you're dividing by that. You can't divide by 0. So the domain of f divided by G is just like this one, except no -4 and no +3. So parentheses. What about G divided by F? Maroon divided by blue. Well, it would naturally be the same, the same domain as this, -4 to 3, but you're dividing by F. So you have potential for a problem. Does F ever equal 0? Yes, F is the blue function, and it just equals 0 at one point only, this X value, which looks like it's 1.5. So the domain of G divided by F is everything between -4 and 3, except for 1.5. And then there's that domain. Notice it includes -4 and it includes 3. By the way, what is G divided by F of -4, for example? What is G divided by F of -4? Well, G of -4 is 0, and F of -4 is 5. So you tell me, what's 0 divided by 5? It's just 0. What about G divided by F of -3? Well, G of -3 is 1, and F of -3 is 4. So what's 1 divided by 4? It's 1/4. What is 2 more, and then we're done? G times F of 0. Well, that's the same thing as G of 0 times F of 0. And looking at my map, G is the red one. So G of 0 is 1. F of 0 is 2. So this is the same thing as 1 times 2. And 1 times 2 is 2. What about F minus G of 2? That's the same thing, of course, as F of 2 minus G of 2. Looking at my map, F of 2 is -1. And G of 2 is +1. So -1 minus 1 is -2. We will see you later. We still need to talk about compositions, but that will come in a different video.